It's a pleasure to welcome you to this special edition of our Manufacturing 4.0 webinar series. We have hosted sessions like this before, and the response has always been very encouraging, which is exactly why we are bringing the series back. There are mainly two reasons for that. First is the level of interest and engagement from all of you. Your thoughtful questions and feedback have inspired us to keep exploring the topics that truly matter to you. The second reason is that in today's rapidly changing day and age, where data is often described as new oil, deepening our understanding of digital implementation is the key. The more we learn, the better equipped we are to adapt, innovate, and make informed decisions for our organizations within the manufacturing sector. Now, this time around, we are taking things a step further with bringing more real-world examples, deeper insights, and practical takeaways from the field. So whether you have joined us before or are attending for the first time, thank you so much for being here. We are very happy that you have joined us today, and we are confident that today's session will offer more valuable perspectives on digitalization in Manufacturing 4.0. Now, let me quickly introduce myself. My name is Vaishnavi, and I work as a director at Opsio and also facilitate the team's efforts in the department. Over the years, I've had the opportunity to work closely with manufacturing organizations at different stages of their digital transformation journey. It's a fascinating one and one of the most fast-moving space, and I'm honored to be your host today. Of course, no journey is complete without the right expertise, and I'm excited to be joined by a colleague who brings exactly that. Please join me in welcoming Debulina, our operations manager, a leading voice in overseeing the implementation of AI and ML applications in industrial operations. Debulina brings a strong record in deployments of predictive analytics, intelligent automation, and scalable industrial AI solutions, combined with a practical understanding of what it really takes to make these technologies work on the factory floor. Welcome, Debulina. It's great to have you with us.
Thank you, Vaishnavi, for the kind introduction. I am excited to take us through the real world impact of AI. With that, I'll hand it back to you to get us started.
Thank you, Debulina. Now, let's start with today's session by looking at our agenda. So, we will begin by introducing Opsio, who we are, what we believe in, and how we help businesses embrace digital transformation with confidence. From there, we will move into Smart Production Roadmap, our framework for transitioning from traditional linear workflows to intelligent, more connected manufacturing components. Then we will look at some of the key technologies driving this change, from digital twins to predictive maintenance, and how these are already delivering value in real-world environments. Finally, we will share how Opsio supports organizations in designing, deploying practical yet cost-effective solutions, starting with a proof of concept so you can see the results before making a large-scale investments. So let's start with a quick introduction to Opsio. At Opsio, we see ourselves as a supportive technology partner, working closely with businesses to help them embrace modern solutions without getting weighed down by the complexity that often comes with digital transformation. Our aim is to take on the operational load so our clients can stay focused on what they do the best, that is, driving their core business forward. We operate from two key locations. Our headquarters is in Karlstad, Sweden, and our regional office is here in Bangalore, India. Both teams contribute valuable perspectives and deep technical expertise, working together as one unified unit to deliver meaningful results globally. Our team in India also plays a crucial role in driving global projects and supporting initiatives like Make in India. Over the years, we have been fortunate to build strong partnerships with major cloud providers like AWS, Azure, and Google Platform, and we're also honored to be recognized as advanced partners. Our expertise extends to on-premises technologies like VMware as well, which contribute to a key part of many hybrid IT environments. For us, it's never just about the tools, it's about how we apply them to solve real business problems in a way that is both effective and sustainable. We have successfully delivered many projects across a wide range of industries, and we have learned something valuable from each one of them. So these experiences continue to shape how we approach every new challenge with curiosity, care, and a long-term view. With that in mind, I would like to share a closer look at how the manufacturing industry is evolving in this digital era. AI in Indian manufacturing. As we all know, the role of AI solutions in Indian manufacturing is steadily becoming more defined. Over the past 2 years, adoption has increased 20%, and today, more than half of manufacturing firms report applying AI in some areas of their operations. This is not a sudden shift that we see, but a considered progression driven by the practical needs to enhance efficiency, resilience, and long term competitiveness in an increasingly complex industrial environment. By the end of 2025, it is projected that 40% of all manufacturing investments in India will be directed toward digital technologies, up from 20% in 2021. So this signals more than just an interest in modernization. It reflects a growing recognition that digital capabilities are becoming essential in the sector's long-term stability and growth. The market for AI in Indian manufacturing is expected to grow at an annual rate of nearly 59%, not because of novelty, but because it is beginning to demonstrate tangible value in areas like minimizing equipment downtime through predictive maintenance, improving production planning with real data insights, and enhanced quality control through automation and precise inspections. So these advancements may not always be visible on the surface, but they are quietly reshaping operations in meaningful ways, one decision, one process, and one outcome at a time. While the technological potential is significant as we see, it is equally important to approach this transition with perspective. AI is not a one size fits all solution, nor it is without challenges. Its effectiveness depends not just on the systems deployed, but on the clarity of purpose behind them. Manufacturers who have seen early profits often cite that a focus on specific high value use cases is always better than broad application. Strong collaboration between technology and operation teams, and a commitment for long term capability, not just the short term gains. For AI to support meaningful progress, it must be embedded thoughtfully into the broader organizational fabric, which includes equipping people at all levels with the skills to work alongside these new technologies, establishing trust and governance around the data and making decisions around them, and also maintaining a culture that values discipline, transparency, and continuous learning along the way. So, this transition is not about replacing the resources, it's about augmenting it and allowing individuals and systems to cooperate and operate together more effectively. India's manufacturing sector stands at an important juncture as we see. The pace of AI adoption may vary across organizations and industries, but the direction is very clear. The aim is not to chase the transformation for its own sake, but to move forward with purpose and care. It's about building capability with humility, knowing that every improvement that we make today must support a more resilient and responsible future. In the following slides, we will walk through some of India's most respected manufacturing companies have started their journey and often in close collaboration with OPSU. Through our ongoing collaboration with the Swedish Embassy and Business Sweden, we've had the opportunity to engage closely with a diverse group of Indian organizations that are exploring AI and machine learning with intent and care. While we are very mindful about the confidentiality in our discussions, the organization represented here, whose logos are shown on the slides, span a wide range of sectors including steel, paper, energy, public utilities, and consumer services. Now, what has stood out most across these collaborations is that not just the willingness to explore AI, but an intentional approach to how it is being applied. Whether working with long established industrial businesses or a newer digital native firms, we have observed a consistent and a constant focus on using AI to achieve greater precision, responsiveness, and also adaptability in everyday operations. So these engagements are firmly rooted in real world needs and challenges that they face on a daily basis, which typically includes well defined pilot projects designed to scale as we learn and achieve measurable results, clear and high impact use cases like energy efficiency and process optimization, and a strong connection between technical outcomes and a broader business goals, from improving operational efficiency to enhancing the service delivery. Now, this approach reflects a broader mindset shift across Indian industry, one that values resilience over reinvention, clarity over complexity, and also sustainable progress over a short-term wins. It also shows a growing recognition that AI adoption is not simply about deploying the tools. It's about building capability in a way that integrates with core processes, respects operational context, and prepares the organization for a future that is both data rich and decision critical. With that, I would like to invite my colleague Debalina to take us further into these technologies that are underpinning these shifts and to share insights on how they might inform your organization's journey ahead. Over to you, Debalina.
Thank you, Vaishnavi, and a very warm welcome to everyone. It's a pleasure to have you join us for today's webinar. We're excited to get started and appreciate you being here. Since I have already been introduced, I'll get straight to the point. Today's session addresses a critical shift unfolding across the manufacturing sector. Smart manufacturing and Industry 4.0 are no longer future concepts, they are operational priorities. This transformation goes well beyond automation. It redefines how factories ensure quality, maintain efficiency, and stay competitive. The data is clear across sectors like automotive, electronics, and pharmaceuticals. Manufacturers are turning AI driven quality control as a strategic imperative. Today, we will focus on a key aspect of this evolution: AI powered visual inspection, what it delivers, why it matters, and how industry leaders are adopting it. So, let's begin. Smart manufacturing represents more than a technology shift. Its structural lever for enterprise value projected to unlock up to $12.6 trillion by 2030. The advantage comes from building intelligence into the core of operations. Failures don't wait to be fixed, they are forecasted and avoided. Planning evolves into dynamic modeling, enabling faster and more confident decisions. Quality no longer depends on inspection, it's embedded throughout the process. The financial impact: fewer recalls, reduced legal exposure, and stronger SLA performance. Capital efficiency improves as inventory and resources align precisely with demand. Maintenance becomes a controlled investment, not a reactive drain. The result is not marginal gain, it's systematic resilience, higher margins, and a sharper competitive edge. The value smart manufacturing deliver is made possible by a foundational shift, that is manufacturing 4.0. This isn't traditional automation, it's a new production architecture built on precision, speed, and scalability. Processes become more accurate, reducing human error. Inspection is faster and smarter, accelerating output without compromising quality. Waste is minimized at the source, cutting costs and rework. With every machine and process generating data, decisions become sharper and smarter. And because it's digitally driven, the system scales effortlessly across products, plants, and markets. Manufacturing 4.0 turns the factory floor into a strategic growth engine. At the heart of manufacturing 4.0 lies intelligent automation. And one of the most impactful application is automated visual inspection. Manual inspection creates operational drag. It's slower, inconsistent, and heavily reliant on human capacity. The result is higher error rates, rising cost, and limited scalability. On the other hand, automated visual inspection replaces these limitations with precision. AI and machine learning deliver consistent high accuracy assessments at speeds that scale with demand. Labor intensive checks give way to autonomous systems operating around the clock. Error rates fall, quality improves, and skilled resources can be allocated more strategically. The real advantages come from data. The inspection becomes a source of insight, feeding back into the system, driving faster decisions and continuous performance gains. This is how quality control evolves from a checkpoint to a competitive advantage. So, beyond the performance, there is a pressing operational reality driving the adoption of automated visual inspection workforce constraints. By 2030, the industry could face a shortfall of nearly 4 million workers, with almost half of these positions expected to go unfilled. Relying on manual inspection will no longer be viable. At the same time, the cost of skilled labor continues to climb. Manufacturers are being forced to absorb higher wages while grappling with productivity gaps. This is where AI inspection delivers not only accuracy but scale. While manual methods are capped by labor availability and cost, AI driven systems operate at speeds 5 times faster, with defect detection rates exceeding 90%. In a market defined by speed, precision, and workforce volatility, automated inspection offers a scalable solution that aligns with both operational demand and financial discipline. The business case becomes even clearer when you look at error rates. Manual inspection carries a built in margin for error ranging from 20 to 30%. Fatigue, repetition, and variability all degrade consistency over time. Automated visual inspection, on the other hand, reduces that margin dramatically. Even in complex scenarios, machine learning systems maintain accuracy within a 0.0125% range around the clock. The benefits compound over time. These systems don't fatigue, they improve. With every data cycle, accuracy sharpens and throughput scales. This level of consistency and adaptability isn't just operationally efficient, it directly protects margin, product quality, and brand trust. The strength of automated visual inspection lies in its simplicity. Yet, each step is engineered for precision and speed. It begins at the input stage where cameras, lighting, and sensors capture high resolution visual data designed to detect even subtle anomalies in real time. That data moves into the processing layer powered by machine learning models, edge computing, and cloud integration. This is where intelligence is applied, where the system learns, adapts, and identifies defects instantly. Finally, the output stage, where the insights from the processing stage gets translated into action. Defects are categorized, alerts are triggered, and all data is logged, providing a full feedback loop that drives quality, traceability, and improvement. This streamlined system replaces human dependent checks with intelligent, repeatable precision at scale. Let's look at how this intelligence comes together on the ground through a fully integrated visual inspection workflow. The process starts with high resolution data capture, ensuring every component is inspected with full surface visibility. The data is immediately transferred to the vision system, where it's processed in real time. AI algorithms then take over the next step by identifying surface defects, dimensional errors, or misalignments with speed and precision. These insights are instantly pushed to dashboard, delivering real-time feedback to operators. When a defect is identified, the system initiates automated actions and alerts, prompting operators to either reject the part or adjust upstream machine settings. Finally, flagged parts move into quality control, where corrective steps are taken before defects flow downstream. This function flow transforms quality control from a checkpoint into a live, intelligent, and responsive system, minimizing waste, increasing reliability, and maintaining throughput. So let's understand what does this deliver and where it counts. Visual inspection enhances quality, yes, but its real power is in transforming the entire production environment. Defects are identified early and resolved before they impact downstream operations. Critical processes are continuously monitored, making deviations immediately visible and actionable. Production flow improves as inefficiencies are exposed and resolved. Automation reduces manual dependency, allowing teams to focus on higher value activities by addressing issues upstream. The system reduces costly downtime and prevents non conforming products from progressing through the line. Every inspection feeds a growing body of intelligence, providing data driven visibility that supports operational decisions and continuous improvement. We have now seen the architecture, the function, and the benefits, but what does the data actually show? The numbers speak clearly. AI visual inspection reduces error rates to as low as 0.01% compared to 20 to 30% with manual checks. That level of precision drives down defects and operational risk. Efficiency gains reach up to 40%, while inspection costs drop by 25 to 50%. A real world case shows a 30% reduction in material waste and a 25% boost in product integrity. Most companies see ROI within 12 to 18 months, making this one of the most compelling operational upgrades available today. Let's now take a closer look at how visual inspection is driving transformation across industries through the real world use cases. From detecting micro defects in precision manufacturing to enhancing safety on construction sites, optimizing warehouse operation, and enabling predictive maintenance. These examples showcase the reach and versatility of the technology. This isn't limited to automation at all. It's about enabling faster decisions, reducing risk, and driving efficiency at scale. Here is what that looks like in practice. One of the most immediate applications is in packaging quality, where even a minor defect can lead to costly recalls or damaged pan test. AI powered cameras continuously inspect glass, plastic, and flexible packaging for cracks, scratches, or tears, identifying imperfections in real time. Only flawless products move forward. Defective units are automatically flagged and removed from the line before they ever catch or reach a customer. And the results are fewer recalls, stronger brand protection, and higher confidence in outbound quality delivered at production speed. And this extends beyond primary packaging to include secondary materials where defects can be harder to detect but equally costly. Cameras integrated with machine learning models capture and analyze visual data across packaging lines, identifying cracks in glass, scratches on plastic, or damage in flexible packs and boxes. Only defect free units are cleared to move forward. Everything else is flagged instantly for removal or review. This safeguards the end to end packaging process, reducing returns, lowering rework costs, and preserving customer trust at scale. AI visual inspection also plays a critical role in product safety by detecting foreign objects inside sealed packaging. Using advanced computer vision, the system can identify contaminants like plastic, metal, or dust inside transparent containers at full production speed. These anomalies are flagged instantly, preventing contaminated goods from ever leaving the facility. This reduces the risk of product recalls, protects customer safety, and strengthens regulatory compliance, all while maintaining throughput. Another critical use case is barcode and label verification, essential for supply chain accuracy and regulatory compliance. AI powered systems use optical character recognition to check label placement, print clarity, and the accuracy of barcodes, QR codes, expiration dates, and batch numbers. Errors in labeling are detected in real time before they disrupt inventory tracking or introduce compliance risk. This ensures every product is traceable, correctly labeled, and ready for distribution, with fewer manual checks and fewer costly mistakes. AI visual inspection also ensures correct product placement, verifying that the right number of items are packed in each unit. Vision systems count and validate product quantities in real time, detecting missing or extra items as packages move along the line. This level of precision helps avoid underfill, overpacks, and misplacements that could lead to customer complaints, rework, or compliance issues. It's a straightforward application with high impact, protecting brand reliability, improving packaging, and accuracy at scale. Another high impact use case is monitoring package consistency, ensuring each unit meets exact volume and dimension standards. AI vision system assess fill levels and package uniformity in real time, detecting underfill or overfill containers as they move through the line. This eliminates variability, prevents compliance issues, and protects customer trust, especially in regulated industries or volume sensitive markets. Precision here isn't cosmetic, it's essential for brand credibility and product integrity. Tamper evidence and security verification is another critical application, especially for products where safety and trust are non-negotiable. AI-driven imaging system inspects seals, caps, and security stickers in real time, ensuring they are intact, properly placed, and visibly unbroken. This is essential for industries like pharmaceuticals, cosmetics, and premium goods, where any complaint in packaging can damage both consumer confidence and brand reputation. It's a proactive safeguard, protecting product integrity before it ever leaves the production floor. Correct product orientation is another area where AI vision adds precision, ensuring items are positioned accurately before packaging, labeling, or sealing. Systems detect whether products are facing the right direction and the labels or security decals are correctly aligned. Misaligned items are flagged instantly, preventing downstream errors. This is especially important in industries where packaging orientation affects both safety and presentation, such as pharmaceuticals, cosmetics, and consumer goods. By ensuring consistency at this stage, manufacturers avoid rework, reduce waste, and maintain packaging integrity across the line. Now, the final step in the visual inspection process is automated sorting, where robotic systems remove non conforming items from the line. Powered by high speed cameras and AI algorithms, robotic arms identify and extract defective products instantly without interrupting throughput. This enhances efficiency in high volume operations and reduces the need for manual intervention, lowering labor costs and improving consistency in rejection handling. The result is a fully closed loop system where inspection, detection, and action is taken without showing down the line. Now that we have explored the use cases, let's shift our focus to the implementation side. How these AI visual inspection systems are actually brought to the life on the production floor. We'll look at the core components, deployment workflow, and what it takes to go from pilot to production ready. Let's start with what powers the front end of the system, that is the input layer. This is where precision begins. High resolution industrial cameras, thermal sensors, and structured lighting systems capture every detail, ensuring full surface visibility under varying conditions. Lenses and filters are tuned focus, polarization, and glare, while depth and proximity sensors like LiDAR and infrared enhances dimensional accuracy. Edge units process data on the spot, reducing latency, while real-time transmission is handled via Ethernet, Wi-Fi, or 5G, depending on the environment. This foundational layer ensures that what's captured is accurate, stable, and immediately ready for intelligence use. Once data is captured, it moves into the processing layer, the intelligence engine of the system. Here, machine learning models analyze images in real time, detecting defects, anomalies, and pattern deviations with high precision. Depending on the setup, processing can happen on the edge server for low latency or be scaled through cloud platforms like AWS, Azure, or GCP for broader system integration and storage. Key functions like frame grabbing, deep learning interface, and application logic trigger automated decisions. These are then passed through APIs that connect directly with controllers, ERP, MES, or IoT systems. The result is a seamless pipeline from image to insight to action, enabling fast, automated responses and centralized visibility across the operation. The final layer is output, where insights become actions. Dashboards provide real time visibility into inspection results, defect trends, and quality metrics, customized to operational roles and decision layers. The system triggers alerts via email, SMS, or in platform notification the moment anomalies are detected, enabling rapid intervention. Automated reports and quality logs are generated for compliance and traceability. These outputs can integrate directly with SCADA, MES, or ERP platforms to extend automation across the enterprise. When needed, robotic systems respond automatically, removing defective items or adjusting process parameters on the fly. This is where AI moves beyond analysis to deliver real operational control. Now that we have seen how AI visual inspection flows from input to output, let's shift gears and talk about the deployment side. How do you actually bring this to life on your production floor? What models, environments, or integration paths should you consider? Let's explore the deployment approaches that can make this system work for your specific use case, whether it's on the edge, in the cloud, or a hybrid of both. Now let's talk about something interesting where all this AI processing happens. How I wish I could take a quick poll right now to understand whether your servers are hosted on premises or in the cloud. Either way, we are fully equipped to handle and process data in both environments. The cloud offers scalability, flexibility, and remote accessibility, which are ideal for companies looking to expand rapidly. But on prem solutions, they provide greater control, faster data processing, and enhanced security, especially for industries with strict compliant requirements. Of course, there are trade offs. The cloud may introduce latency and security concerns, while on prem requires higher upfront investment and is less flexible for scaling. And then there's cost efficiency. Cloud based AI workloads, especially those demanding high performance GPUs, can become expensive. So, which one is right for you? It depends on your priorities. But before we answer that, let's dig deeper. Would you rather catch defects after production or as they happen? Let's explore that answer. This is where it gets really exciting. AI powered inspection can operate in two ways: online processing or offline processing. Online processing stores data for later analysis. It's great for deep insights, but imagine realizing a batch of defective product after they have been shipped. Not deal, right? Offline processing, on the other hand, works in real time catching defects as they happen. It's like having an AI inspector standing on the line, making adjustments before mistakes turn into costly problems. Think of it like Cricket's decision review system, where online processing is like the third umpire reviewing footage and analyzing past data to identify trends. And in offline processing, it's like an on field umpire making real time calls, and AI is flagging issues immediately, preventing defective products from moving forward. So, which one fits your business better? That again depends on whether you need real time defect detection or better post production analysis. Either way, AI makes sure you stay ahead of quality control challenges. Now, let's talk about something even more exciting, and that is Edge AI. What if we could bring powerful AI solutions directly on prem without needing an entire data center next to production? Well, that's exactly what's happening. With the latest advancements, AI processing doesn't need massive infrastructure anymore. Imagine having a supercomputer the size of a desktop capable of training and running machine learning models right on your factory floor. Sounds futuristic, right? Well, it's happening right now. Take a look at the bottom right image. That's NVIDIA's latest AI hardware. It can process 200 billion LLM parameters locally. This eliminates dependency on cloud providers, reduces latency, and ensures maximum security. AI is evolving and it's becoming more powerful, compact, and cost effective with the flexibility to deploy across any environment. So, what comes next? Let's explore the future of visual inspection. Looking ahead, visual inspection is poised for even broader impact. Driven by speed, intelligence, and scale, adoption is expanding beyond manufacturing into sectors like healthcare, logistics, and food safety, where real time defect detection can deliver both economic and compliance value. Advances in edge computing will enable immediate decision making on the line, reducing delays and enabling closed loop control. Integration with robotics will streamline entire production flows, enabling automated end to end processes. Deep learning models will deliver accuracy even further, while cloud based systems will make deployment easier and more scalable for businesses of all sizes. The future isn't about replacing people, it's about equipping operations with intelligence that scales, adopts, and delivers measurable impact. While we have focused on manufacturing, computer vision is already making waves across other sectors. From construction sites to logistics hubs and infrastructure networks, AI vision is turning complexity in control. Picture a large construction site with materials, crews, machinery in constant motion. Without AI, it's noise. With AI, it's orchestrated. Whether it's real time monitoring with drones and cameras detecting risk before they escalate, or tracking progress to flag delays before they disrupt timelines, or optimizing material use, reducing waste, and triggering reorders automatically, or keeping labor, material, and budget data aligned and under control. AI powered fusion system is already transforming how industries operate, from railways to warehouses to agriculture. It's delivering measurable gains in efficiency, accuracy, and scale. The future of inspection isn't ahead, it's already in motion. So, with the groundwork laid and the value clear, I'll now hand it over to Vaishnavi, who will walk us through how we turn interest into execution and help you take the first step toward real world impact. Over to you, Vaishnavi.
Thank you, Deblina, for sharing those insightful use cases and explanations. As we often remind ourselves, it's a practical perspective that helps us truly understand and appreciate such complex technologies. Now, let's summarize the key benefits of the solutions and look at the cost aspect as well. The first key benefit we can get from the solution is that higher hit accuracy. AI solution offers over 99% of accuracy, helping to ensure that nearly every product meets quality standards. In contrast, manual inspections can sometimes have error rates as high as 30%, which may lead to costly reworks and product recalls and even impact brand trust. So, by significantly reducing these risks, AI solution brings a dependable layer of quality assurance within the production team. Next is automated detection. The AI solution runs continuously around the clock without fatigue or distraction. So this consistency means fewer defective products reach customers, resulting in greater satisfaction and a fewer warranty claims. When it comes to quality control, AI solutions can inspect up to 5 times more products per hour than manual methods. So, this increased capacity supports production scaling and allows quality control teams to devote their expertise to more sort of a complex and value adding activities, improving overall effectiveness and supporting the sustainable growth. Now, in terms of cost, the solution is priced at approximately 90,000 per month. Now, while this might seem like a significant commitment upfront, but it's helpful to consider the broader context to it. For example, let's assume a company inspecting 10,000 products daily, and with a 2% error rate, they would see around 200 faulty products per day. Now, with an average rework cost of 500 rupees per product, that's a daily loss of about 1 lakh. Now, by greatly reducing such defects, AI solution can help us recover this loss, often paying for itself within a few months after implementation. Beyond reducing the defects, the system promotes consistency and efficiency, delivering sustained value that supports the organization's broader goals. So rather than viewing this as a cost, it's more accurate to see as a thoughtful investment, one that brings clear returns and also contributes meaningfully to ongoing operational success. Now, by now, you might be wondering or even wanting to ask an important question, and that is how can these ideas be applied in manufacturing environments without introducing unnecessary disruption or even the complexity? The answer is very straightforward. It begins with intentional, manageable baby steps. So at Opsio, the approach focuses on integrating with existing workflow, not replacing the resources. Even in well-established manufacturing settings, meaningful progress starts without a major overhaul. So our usual approach is that we begin with a single focused use case, whether it's a specific machine, process, or production line. Introduce intelligent technology carefully as a complement rather than a substitute. Often, IoT sensors and analytical tools can be added onto existing equipment, preserving the proven assets. Allow early results to build confidence again. When tangible improvements become evident, scaling is both logical and cost effective. And also for the organizations that are planning new equipment investments, early involvement ensures these assets align seamlessly within the broader digital framework, creating a coherent and an efficient system from the outset. So, with this clear intent and thoughtful design, transformation becomes not only achievable but also sustainable and well aligned with operational realities in the production. Now, to help you take that first step, we are offering a complimentary proof of concept discussion. So, our aim with this is that to have a conversation that is grounded in your business context, wherein you will bring in your experience and knowledge of the operations. We bring the technical perspective, implementation experience, and solved challenges throughout our journey. And together, we explore where targeted digital interventions could create a meaningful impact. And if the conversation feels valuable to proceed, we will design and deliver a small scale implementation, allowing you to evaluate value before committing to a broader investment. So please feel free to reach out to us by either email or phone if you like to explore the discussion with us. And also you will find a short feedback from this chat. Once submitted, we will be in touch to schedule your POC session. Now, as we close today's session, I want to thank everyone for your time and engagement. We hope this discussion offered not only useful information but a deeper perspective on where manufacturing is heading and how digital tools can support the transition in a thoughtful and a deliberate way. A special thank you to Debrina for such a wonderful insights and perspective on the technology. They've added a depth to our today's dialogue. In today's session, if it has sparked a question or an idea, we would welcome an opportunity to continue the conversation. You can also tune into our upcoming session during the month of August, and we look forward to continuing this exchange with you all. And if you like to stay connected, we invite you to follow us on LinkedIn at opsio.india, where we share updates, reflections, and practical insights from across our work. Let's approach this journey with care by starting small, having a vision for long term. While building the intention, let us also learn and share as we move ahead and help shape the future of manufacturing together. Thank you so much, and we wish you a wonderful day ahead.